Hey everyone, welcome to Around Queens. I'm your host, Luchia Dragosh. Today we are at Vaughn College and we're visiting this 3D printing lab, which also hosts the UAV club of the college. And there are different kinds of printers. Actually, one is printing at the moment, but there are different kinds of printers, and we'll go over each one so you can see it in action. And the cool thing about this room is that they design the drone parts on software, and then they print it on these very printers, and they build the drones from the parts that they built. And then they go to a competition and they compete with it, which is absolutely amazing, and it's a lot of fun. So let's go check it out and have some fun.
My major is mechatronics engineering, which basically combines mechanical, electrical, computer, and programming skills. So to implement that in real life, we started off with the UAV club, which is basically a combination of all of it. So over here we design frames, we build it, we put it together, program it, and we take part in competitions like AHS International, which is American Helicopter Society. So for the last few years we've been doing competitions, and last year we got second place in manual category.
What is the process that they go through?
The freshmen, when they come in, we usually start off with, we see how dedicated they are. We start them off with building racing drones, because they're like, it's more like a fun thing, it's more of a hobby. And once they know the basics, once they learn that, then we start off with putting them on competition teams. So when it comes to competition team, they actually know what they're doing, unlike earlier when they don't know a lot of stuff.
What is the difference between this printer and others?
So this printer is unique because it uses resin instead of filament, which is a
What
liquid.
is a resin?
It's a liquid that then creates the print. So essentially what happens is it starts from the bottom and works its way up, which is also unique to this printer. The resin is hardened by a laser that goes around at each layer of the print, creating a print from the bottom up.
Does it go deep?
So it's just this thick, and as each layer builds, it raises up and up and up until you have a complete print. As opposed to other printers, which work from the bottom their way up, so that you have a complete print from the bottom up. This works from the top to the bottom of the print in reverse order.
That is interesting. So the water, the liquid, does it raise this as well? The resin, does it raise as well?
It doesn't raise because it gets hardened by a laser that's within it that hardens the resin and then creates that. And then after the print is done, it's kind of sticky. You can actually touch it if you want. It's sticky, so we have to actually cure it in UV light, and then it becomes a full print, as opposed to other printers where they come out already hard. This one needs to have a little bit more work done to it because of the unique resin that it uses, as opposed to filament used in other printers.
And what is this part?
This part?
No, the actual, what did they print?
These are supports. This is an airplane, actually. I can take it out for you.
Okay.
It's an airplane, a rocket.
Oh.
Yeah.
Oh, I see.
Exactly.
So you cut those parts, the mesh, the net.
They're called supports. Essentially, the program that's used automatically puts those in, because you can't just have a flat surface on the bottom to print, otherwise it would fall off. It needs these supports in order to hold it from falling back into the resin.
You built this drone.
Yes.
Walk me through the process.
Okay, so for our competition, we have a task that we need to complete. So the task that we need to complete is we need to deliver a letter, fly to another objective, pick up a letter, and then deliver that. So in order to accomplish these goals, we've designed parts that can fit those needs, because this competition requires us to have individual components that we've created, not something that we bought off the shelf. So in this case, we've gone through and we've designed several different iterations of this frame to find the best fit, to find the best performance that we can get, the most stability and the most rigidity in flight. So we have different components here that we've designed using CATIA. We have the top piece, we have the slide, we have the rack, we have the claw mechanism. And then what we do is we go ahead and print those out using a 3D printer, which allows us to prototype really quickly and then produce a product. And then we assemble it all together to create a drone like this.
So, how do you know what parts are in the drone? Did you have to break a drone apart?
No, we've gone through and we've built our own drones from scratch. So we have racing drones and photography drones that we've just built. So the second you come into the club, the first thing that you do is someone gives you a project to work on. You work on a drone, you create your own drone, and then you have the understanding of the skills that you need to build a new drone. You understand how it works, the different components of the drone. And once you have that understanding, you can go ahead and make a drone of your own using components that you've sourced and you've purchased and a frame that you've created.
Is there more advantages to a drone that you built on 3D than versus the one you buy?
Well, the thing with a 3D printed drone is that you can, while it may not be as strong as a drone that you buy off the shelf, something made of say carbon fiber or fiberglass, this allows you to create a drone that meets your specific specifications. So if you look at this drone over here, I have holes in different places. These holes allow me to slide a custom piece on, for me to just to put this piece on so that I can use this drone for a different purpose. If I purchase something off the shelf, I won't really have these holes or these slots for me to fit aftermarket components into. So which is why we 3D print. Instead of buying specific frames like this. Also, 3D printing allows us to prototype rapidly. So we make a product, we print it. If it doesn't work, we change it in some way, and then print something that'll be better or fit the purpose a little bit more, a little bit better. This is the one we printed most of the components for this drone on. So the frame was printed on this printer. The standoff over here was printed on this printer. This little slide over here, I don't know if you can see this purple thing over here. I don't know if you can actually tell, but it's the purple piece that's inside here.
Okay.
That was printed on this printer, but everything else was printed on the resin printer. So we used this printer for the claw, the slide over here, and the gear.
And why you can't print that on this printer?
Well, this one isn't as precise. And it's not as strong as this printer. So we have different printers for different purposes. This one, if you want a part that's very fine detail. So like a gear has all these different spokes that you need to be precise so it meshes with the other components. And that's why you would use a printer like this, because it's more fine, it's more precise. It takes longer to print and the material is more costly, but the trade-off is that you have a more accurate part.
Fine too. What are the skills that you need?
First of all, you need to know how a drone works. You need to know how to build a drone. You need skills.
So the mechanics,
Yes. You need to understand how to program the drone in flight, the flight software that we use. This particular one runs on something called KISS. Keep it simple. So that's the flight software that we use for this specific flight control in the drone. So you need to know how to program that software. You need to know how to calibrate it for flight, how to use the controller. Then you also need more practical skills like programming. Soldering. So you need to know how to solder wires together, make proper connections so that the electricity flows to all the components that it needs to go to. You also need to learn CATIA, SolidWorks, whatever 3D programming software that you'd rather use. I'm using CATIA right now because that's the one I'm best at using, and it's the one that allows me to create parts as quickly as I can.
So how would you take all these skills that you learned in the college and then apply it once you start working? Where could you apply the skills in what kind of job work?
Well, I can actually talk about this specific drone. This one was built to pick up and deliver letters.
Oh.
So a letter would, in this claw area, a letter would fit in here, and this drone would just take the package around. So that's one practical use for drones in general, is package delivery. Then you have obviously photography, as a lot of people have seen how drones have been used. But package-based delivery, drone-based package delivery is something that's taking off recently. I remember reading in the news recently that China has actually started taking steps to ensure that, to allow private companies to deliver packages using drones. So this is a practical use in the real world.
So this is a newer edition of printers that we got right now. It's called the Ultimaker 3 Extended, right? So what it does is it's the newest version from Ultimaker, and it has a really good print quality, and it can print a lot of different types of materials rather than your conventional PLA and ABS. So this printer has basically let's say we want to print something, right? And we could fully customize how we want to get it printed. So we could adjust what the support material is going to look like. We could adjust how it's going to print our material on the part. And so they use a software called Kira, which where you could adjust like the filament. Where you could adjust the filament, you could adjust the infill. That's how much material you have in a certain amount of space that we have. So it's basically more customizable. That's why we have it in one of the newer additions to the lab.
That's it for today's show. I hope to see you next time on Around Queens, and make sure you check us out on qptv.org/aroundqueens. I'll see you next time. Bye.